Go ahead and read. Someone.
I will create a proof for the alternate exterior angle theorem flowchart 2-column 1 paragraph.
Beautiful. And what's what's the title of today's lesson?
Alternate exterior angle theorem?
Interior.
Oh, interior, I'm sorry.
That's all right. Alternate interior angle theorem, and we will be writing the proof for that theorem. Because remember, when we were first introduced to proofs, our first one was the vertical angle theorem. We weren't allowed to use theorems in a proof until we proved them. Till we said, no, this thing is true and it's okay. All right? So that's what we're going to do with the alternate interior angle theorem today. All right, we're going to start with this page, the single page. I'm going to zoom in nice and tight and make it bigger. You're going to lose the screen live for just a moment. It'll be back up. All righty. So the first thing we need to do is look at the theorem itself, which I've printed for you here at the top. If two parallel lines are cut by a transversal, then alternate interior angles are congruent. What is the hypothesis of this conditional statement? As you need to recall from way back when, what's the hypothesis of this conditional statement? Very nicely done. Without the word if, the hypothesis is two parallel lines are cut by a transversal. Please underline that once. If you're using different colored pens, choose a color and that will be the hypothesis color for today. Write the hypothesis in the box next to given. All right, everyone have the hypothesis written? You'll need both. And I'm starting on the single page. Thank you. Now we need the conclusion of this conditional statement. What would be the conclusion? Yeah, is that the one you were thinking? Okay, remember it's without the word then. So the conclusion is alternate interior angles are congruent. So please write that by the prove. The conclusion is what we are trying to prove today. Now we have a box that says construction. This empty box is for us to draw some sort of sketch that'll help us see exactly what we've been given. So we'll use the hypothesis to draw our sketch, and then we'll label it to help us try to get toward the conclusion. According to the hypothesis, what am I drawing? What am I drawing? I'm drawing parallel lines. All right, so here's one line, here's another. They totally don't look parallel, but I can use this little extra arrow head to say, hey, they're parallel, even if they don't look it. So what else am I drawing? A transversal. Some other line that intersects these two that I already have. I'm drawing a transversal. There is my transversal line. I'm going to make my arrowheads, los flechitas, look a little darker. All right, now that I have my parallel lines and my transversal, I've drawn everything that the hypothesis has told me to draw. So now I need to figure out how I need to label this to help me get to the conclusion. According to the conclusion, what kinds of things do I need to be able to talk about? I have to be able to talk about angles, and specifically the alternate interior angles. So I need to label my angles. We have three ways to label angles. We can name them by their vertex, which means we're going to have to put points and letters. Can you see how cluttered that might get? Yeah. I could name them by their sides and the vertex, but now we're talking 3 points per angle. That's going to get really busy too. Or I could name the angles by some number and just slap a number on them like your social security number and give the angles one of those and then be done. So let's do that. Let's give each of our angles a number. Shout out some numbers for me.
5,
4,
10, 2,
69, 10,
Oh, I already have a 10. What was that?
13.
13 and 12. All right, there they are. They are in no particular order. We didn't even start at 1. We didn't even use the number 1. No one cared. These are just numbers we assigned to the angles. We now have everything we need to start with so that we can begin writing our flowchart proof. Here it is, very, very lightly drawn. The photocopier did not like the pencil that I used apparently. So I'm going to darken this box right here because this is the very first one I'm going to fill. And the very first statement that you write in your flowchart is always the hypothesis. What was my hypothesis again? That's the conclusion. Thank you for reading it. Will you find the...
Parallel lines are cut by a transversal.
Thank you very much. The hypothesis was the other part of that statement. 2 parallel lines are cut by a transversal. Thank you very much, both. You gave the conclusion earlier, so hang on to that one because we're going to ask for it before we end, okay? And that we get to read it again. All right. Now, our conclusion was asking us to find the alternate interior angles, so let's go ahead and do that. According to our construction, what are the alternate interior angles? Well, let's think back. In order to find the alternate interior angles, these angles have to be on opposite sides of the transversal. So you're going to have angles here and angles here. And then you need those angles to both be in between the lines getting cut by the transversal, which means both of them have to be there. Yes?
I need to see Ivan at the office.
Thank you.
So it'd be 10, 2, 7, and 69.
10, 2, 7, and 69, but now we need to pair them properly. The only line they can share is the transversal. So if I pick 10, I can't pick 2 because it's sharing both the transversal and the other line that's creating it.
So it'll be 10, 69.
Perfect. So it's going to be 10 and 69 and 2 and 7. So in this next box right down here, I'm going to list out the alternate interior angles. So my alternate interior angles are angle 10 and angle 69, angle 2, and angle 7. I'm going to scoot this up a little higher so those in the back can see it.
Thank you, ma'am.
You're very welcome. And I used the picture to get me that information, didn't I?
Yes.
And so our reason, you can see a very faint line right here. That's where we're going to write our reason. We're going to write by construction because it was the construction that we drew that allowed us to say that. By construction. Oh my goodness, that looks like a G. It's supposed to be a Y. All right, so far so good? All right. Now, at the start of the day, I had said that whenever you're given a theorem, if you're going to use it in a proof, you have to prove that theorem first. If we look at this list of theorems and a postulate from the other day, that postulate's different, isn't it? What's the difference, do you think, between postulates and theorems? I'm telling you right now, theorems you have to prove. You can't use them without a proof. What about postulates? Do we have to prove them before we can use them?
No.
Yeah, we don't have to. Because postulates are those things that people just take for granted. You're going to be like, oh, this is a postulate? Okay, boss, I will use it. And you don't question, you don't ask, even if it makes no sense to you, you just go, okay, boss, whatever you say. All right? So look at this postulate, the corresponding angles postulate. It says that if I have two parallel lines cut by a transversal, then corresponding angles are congruent. Do I have two parallel lines? Are they cut by a transversal?
Yes.
So then the corresponding angles are congruent. Granted, that's not what I want. At the end of the day, I want the alternate interior angles to be congruent. But this thing has angles congruent. And so it could be useful. So we're going to go ahead and use it. So this next box right here, let's put in the corresponding angles. Notice that I have to list which ones are the corresponding angles before I can say which ones are congruent. So I'm going to scoot it down so we can see our construction. According to our construction, which angles are the corresponding angles? Let's think back. For them to be corresponding, they have to be on the same side of the transversal as each other, and one outside and one inside.
5 and 10.
5 and 10. And again, let's add in that one little bit of the only line they can have in common is the transversal. So scoot 10 down a little bit. 5 and
7.
7 are the corresponding angles. Are there any other pairs of corresponding angles? 4 and 13? 4 and 69. Okay. Any others? 10 and 12? And someone else to give me the last pair? 2 and 13. Very nice. Thank you. And I'm going to make that box nice and dark so I can see it. We wanted the corresponding angles because we could use the postulate to say what? What did the corresponding angles postulate say? It says if we have two parallel lines cut by a transversal, then corresponding angles are congruent. Do we have a list of corresponding angles? Then the pairs are congruent. So this next box, I can write that each one of these pairs has a congruent sign. Whoops. I'm going to learn to write today. Sorry that it's messy.
So this is a congruent sign.
Okay, great question. What does the congruent sign look like? The congruent sign looks like an equal sign, but it has a little squiggly on top. It's like a Mexican equal sign. It's the tilde, right? Did I say it right?
Yeah.
Okay. So put a tilde on top of the equal sign. and it goes from equal to congruent. And what was the name of the postulate that I used to say this?
Corresponding.
The corresponding angles postulate. It was written right over here, off to the side. So we're going to write that on the little ghost lines that you see here. Ooh, excuse me. So far, so good?
Yes.
All right. Let's go back up to the construction to see if there's anything else that we notice. Looking at the construction, if I hide all but just two of the lines that are intersecting, do I notice any other angle relationships? Well, if I look at 7 and 69, I see that they form this straight line, don't they?
Yes.
That makes them a linear pair. And a linear pair adds up to 180, which is awesome, except that doesn't tell me congruence. And I really want to try to keep a congruent angle thing going in this proof. That'll just make things so much easier. Excuse me. I have that they're supplementary. They add up to 180, but that doesn't help. So what other pair do I see here? What if I look at 7 and 13? What relationship is that? It does feel like it's going to be some sort of alternate because they're on opposite sides of the transversal. But if I covered up part of this picture, I no longer have a transversal. I just have two intersecting lines because I've hidden the rest of the picture. If you'll put the phones away, please, gentlemen. Thank you very much. So what relationship do I have between 7 and 13? They would be the same measure. They would be congruent angles. But why? Why are they congruent? Yeah, you're not wrong. It's because of the way they're cut. They have a special name, this relationship. I'm going to start to write the name of the relationship. As soon as you recognize what it is, feel free to shout it out. Very nice. I got one letter in and you already had it. They are vertical angles, and we're going to list out all the vertical angles that we see here. I already gave you angle 7 and angle 13. It's up to you to find the rest. Go. Angle 69 and angle 12. Very good. Another pair? Angle 5 and angle 2. And another? Angle 10 and angle 4. Very nice. And again, this was given to us by the drawing. Now we had said, or you had said rather, that these angles are congruent. And so I can immediately go from them being vertical angles to them being congruent. The question is, what is the name of the property, theorem, or definition that allows me to say this? The very first thing that we went to prove this year was the vertical angle theorem, wasn't it? That was the first theorem that we worked on. And it was an assignment that's due. Many of you haven't finished it yet. And if it's because you weren't remembering how to do the proof after that lesson, hopefully today's will help you. You can go back, fix it, and then turn it in just as soon as you can. Stay a few minutes after school, finish it up, and get it in, okay? But we looked at the vertical angle theorem. What did the vertical angle theorem say? It said very formally exactly what you had just said. You said that these angles were the same, which means that they are congruent. So the vertical angle theorem says the vertical angles are congruent. So that's the reason we're able to go from them being vertical angles to saying that they're congruent. The vertical angle theorem says so. And we're allowed to use the vertical angle theorem now because we've already proved it. Or at least you should have if you've already turned in the assignment. Vertical angle theorem. We're doing pretty good on our flowchart proof. We only have 2 boxes left to fill and only a few more lines to trace out. So let's go back and try to remember what our goal was. What were we trying to prove? What's the conclusion of this statement?
Alternate interior angles are congruent.
Very nice. Our conclusion is alternate interior angles are congruent. Which angles are the alternate interior ones? Yes. Which angles are the alternate interior ones?
They're on opposite sides of the triangle.
You're right. Didn't we list them already?
Yes.
Here they are. So if we can somehow say that these angles right here are congruent to each other, so if we can make this statement, then combining this one right here, which is the list of our alternate interior ones, and this, which is a list of those being congruent, we can combine them to say that the alternate interior angles are congruent. With me so far? Combined. We're going to combine those statements. We just have to figure out how to get to that one. Okay? So I'm going to zoom in real close here on the right-hand side, the right-hand corner of my paper. Don't worry, I'll come back to the left-hand side if you haven't gotten a chance to finish writing. Let's look at this. I want angle 10 is congruent to angle 69. In this group of congruent angles, do I have angle 10 or angle 69 listed?
Yes.
Yes. So you get to pick one of the two to use. Doesn't matter which one, pick one. 10. Okay. So we're going to look at 10 and 12. I'm going to write a comment about that over here off to the side. I'd like you to write it with me. I have angle 10 is congruent to angle 12. With me so far? Now, looking back at this one, I'm looking at 10 and 69. I'm going to look at this other box. Do I have angle 69 sitting in there anywhere?
Yes.
Yeah. Yeah. Oh, I'm so sorry. I didn't move my finger. That one, there it is. I have, according to that, angle 12 is congruent to angle 69. Does this look familiar from algebra?
Yes, ma'am.
Didn't you have this where you had 3 things equal to each other?
Of course.
Do you remember what that allows us to do? Not really. Okay, let's explain real quick. All right, I have something sitting here. Yes? Here's a thing. Can you see it? Here's the thing. It is congruent to this other thing. Okay? And then I'm telling you that this middle thing is congruent to this other thing.
So they're all the same.
So these two are congruent to each other.
Yes,
And I can ignore that middle one.
yes.
Okay.
Which is what we have here. This has a name. I'm going to start to write the name of the property here. As soon as you think you know what the name of that property is, start shouting it out. Here we go.
Translation,
Very close.
transtitution,
Transitive property.
The transitive property. This right here is the transitive property. And since we're dealing with congruence, we need to specify that this is of congruence. And this allows us to make this move right here. Let's go in and select the items that we're going to use for sure, so we can get rid of the stuff we're not going to use and get to our 2-column proof, because we're pretty much done. We're just playing cleanup now. All right, we want 2 and 7. So which angles am I going to use? Am I going to use the one with the 2 or the one with the 7? The one with the 2, says Miss Jackie in the back. That means I can get rid of these others. All right, and so this one. I have a 2, but I want to get to a 7, so I need to find the one with the 7.
You'll say 13.
There it is, 7 and 13, and it also has the 13 from this one, so that helps. I can get rid of these others. Now we're going to go up a level. From this one, the corresponding angles postulate, I'm going to keep the same pairs that I used. I used 10 and 12 here. I need to keep 10 and 12 up here. I used 2 and 13. I need to keep 2 and 13.
Hello?
Yes?
I need Jose De Leon, please, at the office.
He's not here?
Thank you.
Thank you. So I'm going to get rid of those. I'm going to repeat with the vertical angles. I'm keeping 7 and 13. I'm keeping 69 and 12. I'm getting rid of the rest. My flowchart proof is done. There it is. Now to show you how to get it to the 2-column, we need to do a little bit of labeling. What was the first statement we started with?
2 parallel lines.
Are cut by transversal. This one right here. I'm going to label it statement number 1. And now you have 3 paths to choose. You can take the left path, the middle path, or the right path. Which one do you want to take? It doesn't matter. Just pick one.
Right.
The right path, he said. So we're going to go on this one. And this will be statement number 2. The arrow that led us there is that statement's reason. This right here is reason number 2. Following out of this statement, we're going to follow this path. So that means this is the next reason. And here's my next statement. Statement 3 and reason 3. Leaving this statement, we're going to go find the next one. Oh, but notice, we can't move on because look, there's a branch, another path that leads to there. So this isn't the next statement. We have to go up this path to find the oldest statement that we can find. This one. This is our next statement, statement number 4. And the reason that leads to that statement is the reason. This is the reason. The arrow is going into that box. This is reason number 4. Did that make sense?
Yes.
All right, so we're going to follow the statement again. We're going to leave the statement number 4. We end up here at statement number 5. And here's the reason we got to statement number 5, right there. Leaving statement number 5, can we now continue past this junction?
Yes, ma'am.
Yes, because the statements above it on both branches are filled in, which means this is statement number 6. Here's the reason for that statement. Reason number 6. Leaving statement number 6, can we move forward? No, what do I have to do? Go backwards up to this one, and this is statement number 7.
So you're not moving.
Go back once more to find the reason, and then continue forward again. Here's my next and final statement, statement number 8, and here is reason number 8. Do all of our statements have a reason?
No.
No, which one's missing?
Oh, shucks.
You're absolutely right, there's one missing. Which one? Reason number 1. Do you notice how this box doesn't have an arrow going into it? That's what we said our reasons were the arrow's going into the box. This one doesn't have an arrow going into it. So its reason is found right here. Reason 1 will always be the word given. All right, follow me on to your 2-column proof. Label your statements 1 through 8, please. We have about 15 minutes left in class. I want to be able to get all the way through to the very end. So we're doing okay on time. Yeah, you're going to go real quick and come back? Yeah. All right. We've labeled these statements and reasons. So all we need to do is match up each code and fill in our table. This is reason number 1. I'm going to write the word given under reason number 1. And then I'm going to check it off so I know that it's done. Now here's the neat thing. I no longer have to go in order. See the next thing that I uncovered? I uncovered reason number 2. So I can fill in reason number 2 without having to worry about what statement number 1 was, because my labeling has already given it to me. Take the next 3 minutes to fill out your 2-column proof table. I'm going to zoom way, way out so you can see both pieces of paper at the same time. And you'll be able to see I'm going to bounce around on my table, probably filling out statement like 6 or 7 before I even do statements 2 or 3. Okay? You should need to be able to read my work up here because you will have all the same information on your own flowchart proof. All right, here we go. Try to beat me. Ready?
I already beat you.
Steady? Go. Race. Termina antes que yo. Finish before I finish.
Oh, that's race.
It's a race. Try to beat me.
Okay.
Okay. I promise I won't write as fast as I can write
Please don't
because
miss.
if I do that, I can't read it.
You beat me.
And then I win. The only thing that you leave out in your statement box is anything that you crossed out. Everything else you need to write. Yes. Thank you. As you can see, I'm jumping around already. Gentlemen, I don't think you're gonna win doing
We
that.
already won.
You finished your 2-column proof? All right,
Mentally,
probably. Yeah, we'll finish physically.
Miss, I can't win. I'm going too slow.
Write a little quicker.
And I'll miss up and I'll be pissed off.
Oh, okay. I can understand that completely.
he's a turtle.
Hey, James,
You know what? Ninja Turtles are cool.
No, not. I didn't say he's a ninja turtle. I said a turtle.
He's just a regular turtle.
Well, you know what? Slow and steady wins the race.
That's what I just said. But he didn't win the race. He was a turtle.
You're writing all the little symbols
Mhm.
and all the little numbers. You guys are awesome. Language.
I mean, fudge.
Can't use this recording now.
Man,
This was the best one I had.
if you couldn't use it in the first place, it means it's like intercom.
This is true. I
Twice,
didn't think of it.
not just once.
Hey.
Dude, I'm not even talking to you. Whoa.
That's not an excuse to drop more F-bombs. I'm just saying. Don't do it. This is a no bomb zone.
I don't know what to say. It's funny. Yo, see,
I'm almost
I'm
done.
in last place now.
Are you done?
Yeah.
Woo!
Slow and steady wins the race.
No,
Just like you said.
So City wins the
So
race.
technically, I won.
All right, let's look at, before I write reason number 8, which statements did we combine to get to statement number 8? 6 and 7, says Miss Taylor. All right, so update that reason, because with proof writing, you want to make sure that you're very, very clear as to what exactly you did. So we combined statements number 6 and number 7 to create statement number 8. And when you're done, your 2-column proof should look like this. All right? If you're not completely done with it, it's all right. You'll have time until Friday to get it finished and polished up. Let's go ahead and move the flowchart off to the side. And we're going to work with the 2-column and turn it into the paragraph proof. Now, the first time we did this, when we did the vertical angle theorem, we wrote a rough draft. Do you recall?
Yes, ma'am.
How did we write those sentences? What kinds of things did we do?
We wrote on the way we saw him.
We wrote them the way we saw them. And what did we put between each statement and each reason? We put a word. Started with the letter B. Because! So that's what we're going to do again with our rough draft. But I want you to focus this time on making sure that your sentence begins with a capital letter and ends with a period. That's what I'll be checking when I read through these. On your rough draft, I'm just going to look for, does your sentence start with a capital? Yes? Awesome. It's correct. Does it end with a period? Yes? Awesome. It's correct.
Miss, you have to copy?
Yep, you're going to copy it again. And this time you're really focusing on making sure that the first letter is a capital letter and that your sentence ends in a period. If that's a very important phone call, step outside to take it. Go step outside. Okay, let's do the second one together. All right, I'm going to make sure that that first letter is a capital, and I'm going to write everything else exactly the way I see it, except I'm going to make one change. You notice here on the second statement, I just have this big space, but really I'm listing them. So I'm going to write the word and to show that I've got two things in a list. This second sentence sounds, oh my goodness, it sounds so horrible, don't you think?
It's not.
Because by construction. What? All right, but we feel comfortable on writing the rough draft? All right.
Kind of.
How many sentences will your rough draft have?
Seven.
It'll have 8 sentences because you have 8 statements. So give yourself enough room to write about 8 sentences.
Okay.
Okay, so I took maybe 1 line per sentence, so I'm going to need at least another 6 more lines. More if you write bigger than I do, less if you write smaller than I do.
All right, maybe.
All right, we're going to write second draft now. This isn't our final. This one's still kind of messy. We're going to try to make each sentence sound better than what we have. I'm not saying it has to sound perfect and like an, oh my God, super genius wrote it. Okay? I just want sounds a little better. So help me make sentence number 1 sound a little better. 2 parallel lines are cut by a transversal because given.
Given
Because
two
it is
parallel lines are cut by a transversal.
Given 2 parallel lines are cut by a transversal. Okay, so we can do that. Back here we also had
That's it, because it is good.
because it is given. Either one of those two work beautifully. Okay, so I'm gonna take his, I guess, for now. Yeah, you write yours. Yours is nice. I'm gonna use his. So we're gonna add. I'm gonna use my editing marks from English. Some of you are gonna take the English 2 benchmark tomorrow. So here's some editing marks. I'm gonna insert it is. That's my change. I'm inserting. Estoy poniendo adentro. It is to fix the sentence. And now I'm going to rewrite the sentence. 2 parallel lines are cut by a transversal because it is given. Period. Okay? Let's try to clean up the second sentence. Vertical angles, stuff and stuff, because by construction. Oh my God. All right, help me fix it.
Because it is by a,
Construction?
a
Okay, so because it is by a construction, and you want this first, so I need to capitalize that letter. 3 underlines means capitalize. Because it is by a construction, comma,
So you can start a sentence if you can.
you can't start a sentence with the word because?
I think you should. It's not
You
really-
can't, miss.
Okay, he says you can't, she's saying it sounds weird. This is draft number 2, so we're gonna go ahead and do it.
Okay.
And then on the final draft, you can change it again to get rid of starting with the word because. Don't put up yet. Don't put up yet. We need to finish the sentence.
oh,
So I have because it is by construction, comma,
The vertical angles are.
the vertical angles are. So we added the word the, and we added the word are, and we're going to put the sentence here. And all of this stuff right here is going to go back that way. So we're going to write all that change here in our second draft. Because it is by a construction, comma, the vertical angles are, okay? So I'll let you finish that up. Once you've written your second draft, edit it again and make it sound exactly, wait, don't put up yet, wait.
It's not, sorry.
I know we're running to the bell, but wait. Once you have your second draft and you've cleaned it up and you're like, okay, this is what I really want it to say, wait, give me 30 seconds of your time.
All right.
I want you to write the final draft in your best cursive.
Oh.
Not perfect cursive,
But
not,
that's-
oh my God, your best. Whatever your best looks like right now, your best cursive.
All right.
Due Friday. Thank you very much. Have a great day.